Hello everyone and welcome to this video tutorial. In this video we are going to be talking about the senior cycle perspective questions, and in this video we're going to be going through the absolute basics of perspective drawing. We're going to talk about the picture plane, we'll talk about the horizon line, we'll talk about the ground line, and we will talk about how to obtain what's called the vanishing parallels and what they mean in relation to getting our vanishing points. So in the video we will talk about all of that, and we will actually draw this using our animated PowerPoint, and we'll refer to this 3D model throughout the video as well. So what we're going to do is we're going to start off with our orthographic projection. Here you can see we've got our front elevation and our plan view, and we can see that we have got, when we look down at our plan view, we have got our diamond. When we look in at the front elevation here, you can see that we have got our green and our purple surface, which has been projected back onto the front elevation as seen. What we're going to do then is we're going to find what's called our picture plane. And the picture plane is essentially a surface that sits right in front of our object. And you can see we've got our picture plane labelled. The picture plane is essentially the plane in which we are going to draw the full perspective question on. In order to draw our perspective question on the picture plane, we need what's called our spectator. And the spectator is essentially the person or something that is looking at the object at a particular angle, and we will use the spectator as reference when we're drawing our perspective drawing. Once we've located our spectator, we're going to draw in what's called our horizon line. And we need the spectator here because the horizon line is a line that is within the spectator's eyesight. So for instance, if we look in at the direction of the spectator, you can see that the horizon line is in line with the perspective or the eyesight of our spectator. So we've currently got two things labelled here. We've got our picture plane and our horizon line, and then just down here we have got what's called our ground line. So the ground line is the line or the surface in which the object is currently sitting on. You can see that this cube here is sat on our ground line, and when we look in at the object from this angle here, you can see that the ground line or the ground surface is seen as the line here. So we have our ground line, our horizon line, and we have our picture plane here with our spectator in the middle looking at our cube directly on. What we want to do now is we want to draw this two-dimensionally. The way we're going to do this is we're going to take our picture plane, our horizon line and ground line, and we're going to lay it flat on the ground. The first thing we'll do is we're going to draw in our plane of reference here. So when we're looking down straight on top of the object, this plane here, our picture plane, is going to be seen as a line, and we're going to label that as our picture plane. So if we do this, for example, we have a look down, the picture plane here can be seen as a line. So going back to our three-dimensional view here, the next thing we're going to do is identify our horizon line. And we know that our horizon line is in line with our spectator. So our horizon line is located just here. So for instance, if our spectator is 50 millimeters away from our object, the horizon line is also going to be 50 millimeters away. And then down on the ground here, we've got our ground line just located right here. So essentially we've just taken the object and we've just laid it flat on the ground here. We've taken this plane and laid it flat on the ground. We have our picture plane as seen on this edge here. We have our horizon line, which is this line here, and then we have our ground line, which the object sits on. Now that we have our surface laid out, we have our question fully set up, we can see we have our ground line, our horizon line and our picture plane. What we need now are our vanishing points, and the vanishing points are absolutely essential to determine our perspective drawing. So essentially these points here, or these lines, are parallel when we are not seeing them in perspective. But when we see this object in perspective, these lines are going to meet at a singular point, and they are called the vanishing points. So the first thing we need is we need to identify what's called our vanishing parallels, which are a line that go from the spectator up to the picture plane and then down to the horizon line. The way to find our vanishing parallels is by drawing a line parallel to the outer surfaces of the object closest to the spectator. So bring them parallel from the spectator up to the plan view, or up to the picture plane, and then down to the horizon line. So let's have a look here in our two-dimensional question. We can see from our spectator, we've drawn our vanishing parallels parallel to the outer surfaces closest to the spectator. We brought them up to the picture plane, and then we brought them down then to the horizon line, and we here have determined our two vanishing points. We've got our VP1, vanishing point 1, or our VP2 and our vanishing point 2. This could also be called your VPL, which is your vanishing point left because it's on the left side, and this could be called your VPR, or your vanishing point or, because it falls on the right side of the question. So the next part, what we'll do is I'm going to showcase this, and it is going to have quite a lot of drawing here, but we'll go through it step by step in the animated PowerPoint as well. We are going to essentially draw the drawing in perspective here. So let's have a look at it down in the plan view. What we did here is we have our letter M here. So we've got our vanishing parallels, we brought them down, and we located our vanishing points. What we then did was we brought a line straight down until it hit the ground line. And we know here, because this is on the picture plane, we can bring it straight down to the ground line. So this edge here, or this edge, is directly on the picture plane, which means we can bring it straight down to the ground line. And one of the golden rules with perspective is if there is a point on the picture plane, it is an exact height. So what we mean by that is, if we look in at the perspective drawing here, looking straight down, this distance from here to here is the exact same distance from here to here, because that point, this point here, lands on our picture plane, so that is going to be our true height. Now that we've determined our height line, what we can do with these 2 points now is bring them back to our vanishing points. So let's take this point here, for instance. We're going to bring that up to the vanishing point, and then the top point here, we're going to bring that back to the vanishing point too. Similarly, on the other side, we'll take this point, bring it up to VP2, and take this point and bring it back to VP2. So what you'll be left with is a triangle like so, and on the other side, a triangle as well. What we need to find now is where the edge of the surface is going to stop, and the way to identify it is by going back to our plan view here. We're going to take the outer points of our object and bring them down to the spectator, just like so, and where this line hits the picture plane, we're going to bring a line vertically straight down, and you can see we've got a shape just here, and this shape is essentially the green surface here in spectator, in perspective. Similarly, when we bring our point straight down to the spectator, where it crosses the picture plane, we bring it straight down, and this is the purple surface in perspective as well. So in order then to get the top surface, we're going to go to the top of these lines here, and we're going to join those back to the vanishing points as well. So bring this point, bring it to VP2, get this point, bring it back to VP1, and you can see we've got our top surface here, which is the purple surface in perspective. So what we'll do is let's colour it in just to make it a little bit more visually appealing and to represent it more. We've got our purple surface here in perspective, then we have got our green surface then in perspective, and then similarly we have got our blue surface or our purple surface then in perspective then as well. So looking straight down on top of it, you can see we have got our vanishing parallels to get our vanishing points. We then bring this point then down to the spectator where it crosses the picture plane. We bring it straight down to get our edge view here. Once we have our edge, we get the top of the edge, bring it back to the vanishing point, and then similarly again, bring this point down where it crosses, or at the top of this point, we bring it back to the vanishing point, and then we've got our top surface there. And then as well, we've got our side surfaces here too. So essentially all we've done is we've taken this picture plane and we've laid it flat then on the ground. But how would you represent all of this on the picture plane as if it was in 3 dimensions? We would just do the exact same thing. The first thing we would do is we would find our vanishing points, bringing them up, and we would draw it then in perspective here. And then we would just simply find our edges and our surfaces in perspective then as well. So this here is the complete question in 3 dimensions. All we've done is we've just laid it flat on the ground. So let's have a look at it here, for instance. Here you can see we've got our horizon line, we've got our 2 vanishing points, and then we've got our question then drawn in perspective. But if we look at it from this angle here, you can see we've done the exact same thing. Looking straight down on it, we have got our vanishing points here in the horizon line. We have our object then in perspective as well. So what we'll do is we'll head on over to the animated PowerPoint and I'll show you exactly how to draw this step by step as well. Coming into the animated PowerPoint, we have got our SolidWorks model here as a video, and we'll use this as a visual representation of the question. So having a look at the question setup, we already know this setup. It's an orthographic projection. We have got our front elevation as depicted here, and we have our plan view as depicted here. The first thing we're going to want to identify is our picture plane. And the picture plane, when we look down at the model from the plan view, we can see that it is going to look in at an edge. So we're going to be looking at the picture plane as an edge view, and it's going to be on this point here. So we'll draw in our picture plane, and we can see the picture plane is on this point here, similar in the SolidWorks model here. I just have a little picture here just to show that this is a picture plane. Once you have the picture plane, we're going to identify the horizon line. And the horizon line is the same distance between the spectator and the picture plane. So in this case, the distance between the picture plane and the spectator is 50 millimeters. So the distance between the spectator and the horizon line is going to be 50 millimeters. So our horizon line is the same distance between the spectator and the picture plane. We can see that it is the horizon based on our sunset, I suppose, in the horizon. Lastly, we're going to identify our ground line. And the ground line can be any distance between the horizon line and the ground line. It's not a set distance, but what I would recommend is if the question is 50 millimeters, put your horizon or put your ground line about 70 millimeters down below the horizon line to give yourself enough space to draw your question. So let's have a go through that all one more time. Our picture plane is on this point here as depicted in the SolidWorks model and also depicted in the animated PowerPoint. Our horizon line is equal to the distance between the spectator and the picture plane. And our ground line is a little bit more than the overall height of the object. If the object is about 50 millimeters, I would put the ground line about 70 millimeters below the horizon line. Another relation to note between the XY line, the picture plane, the horizon line and ground line is they are all parallel. And this isn't going to be the case in every single question. Some questions, the picture plane might be off at a slight angle, but if the picture plane is off at a slight angle, the horizon line will be parallel to it. The ground line will also be parallel to it. These lines will always be parallel to one another. Now, once we have the question fully set up, and this is the question now fully set up, we can start drawing the question to try and determine the perspective image of this cube. The first thing we need are our vanishing points. And we need to identify the vanishing points by getting our vanishing parallels. The vanishing parallels come from the spectator and they are parallel to the outer surface closest to the spectator. So we've got VPL1, vanishing parallel 1, parallel to this surface, and vanishing parallel 2, which is parallel to this surface here. Where these lines hit the picture plane, we bring them straight down to the horizon line, which determines the VP1, or which is called vanishing point left, or VP2, or which is called vanishing point right. So these here are our vanishing points determined by our vanishing parallels. Now that we have our vanishing points, we are able now to start drawing this in perspective. So going back to our golden rule, if there is a point on the picture plane, we are going to see that as a true height. So we can see that this surface here, or this surface, is resting on the picture plane. So we can see that the picture plane is here, and this point or this edge is resting on the picture plane. So we can bring that point straight down. And because that point is on the picture plane, we can see that point or this edge as a true height. So in the question, this true height here is 50 millimeters. So because it's on the picture plane, we bring it straight down and we measure up then 50 millimeters. Once that's done, we can take those 2 points. So the very bottom point here, bring that up to the vanishing point. And then the top point, we bring that up to the vanishing point, and we're left with this triangle here. We're going to work with the green surface here. So at the moment, we have got the green surface somewhat in perspective, but we need to find the edge here. So the way to find this edge is we're going to go down to our plan view. We're going to take that point, bring it down to the spectator, just like so. And where this line intersects with the picture plane, we bring that then straight down. And here is essentially the green surface in perspective. So all we do then is we heavy in the lines and then we shade that in green, and that is the full green surface then in perspective. And it is the exact same then for our blue surface. We're going to bring this point up to VP2, bring this point to VP2, and then we're going to take this outer edge, join it to the spectator, where it intersects with the picture plane, bring it straight down. We're going to heavy in the relevant lines and then shade in that surface there, and that is now the green and the blue surface as seen in perspective. In order to get the top surface, we're going to revisit these points here. We're going to take one of these points and bring them up to VP2. Then on the opposite side, we're going to bring that point up to VP1. And here is essentially the surface, or the very top surface, heavy in the relevant lines. And there is the top surface as seen in perspective. Thank you very much for taking the time to watch this video. I hope that you found this helpful, and we will see you in the next one. Take care everybody, and goodbye for now.